Hi everybody, so here's my intent. I'm going to do 124, which was asked last week, but it was the second highest rated one for this week of October 27th. So I'm hoping to finish up with this one, problem 124. What I decided to do is I set up everything kind of from my solutions, but I'm going to explain why I got those solutions. So I'm going to show my free body diagrams and everything like that, and also my knowns and unknowns, but then I'm going to fill everything in as I go along to show you why I did what I did. Okay, 124 says, as shown below, the coefficient of kinetic friction between the surface and the larger block is 0.2. So coefficient between here and the floor is going to be 0.2, and the coefficient of kinetic friction between the surface and the smaller block is 0.3. So that's this right here, which is also why I got this right here. I'm calling this block 1 and this block 2, hence why it's got M1 and M2 here. All right. It says if F is 10 newtons, and this is what F is, there's a force being applied to block 2 right here, and M is 1 kilogram, that means this will be 2 kilograms. This will be 1 kilogram. That's what I got right here. They're asking, what is the tension in the connecting string? So they're asking for what's the tension here. And then the property of tensions of strings is that the tension that's going to be applied here is going to be the same tension that's going to be applied there. So I think what my goal is, what I'm going to try and do, is try and find the acceleration of the whole system. Once I got the acceleration of the whole system, I know that's going to be the acceleration of this block right here. And if I know the acceleration of this block, I can then get the tension force from that second law problem. So the first thing I'm going to do is try and find out the acceleration of the whole system. So for 124, that's why I got both boxes being the system as my first free body diagram. I've written all my knowns and unknowns here. Again, the coefficient of kinetic friction for block 1 is 0.2. Coefficient of kinetic friction for block 2 is 0.3. The mass of block 1 is 2 kilograms. Mass of block 2 is 1 kilogram. And then the force being applied to block 2, that's the force right here, is 10 newtons. So again, I basically said that I'm going to make both boxes my system right here. That's going to give me my free body diagram. Now, oftentimes with my free body diagram, if I have this whole thing being my system, let's kind of sort of draw that like this. Often you draw the normal force as being one force, the weight as being the total weight or something like that. But I've treated them as separate because I know I'm going to have to split these into two parts because the coefficient of friction between both these things are different. So because those coefficients are different, I'm going to strategically make my normal forces and my weights different. And also you can see my friction forces are different as well. So I've got kind of acting on this whole system, two forces in the vertical positive direction, Fn1 and Fn2. Two forces in the vertical negative direction, M1G and M2G. I've got just one force pointing in the positive direction, positive x direction, which is F. That's this same force. They're the same thing. And then I got two friction forces, one from box 1, one from box 2, pointing in the opposite direction of x there. All right. So I'm going to apply the second law, F net equals ma. And I think I'll be able to just do along in one direction. So I'm just going to do the x direction, which is F minus FF1 minus FF2 equals the mass times the acceleration. The mass here is going to be the total mass times the acceleration. I could do the y as well, but what I'm going to do instead is I'm going to treat both boxes as different systems so I can get the y for box 1 and the y for box 2 because that's going to help me fill in these friction forces. So I got the total mass, that's going to be fine. I'm looking for the acceleration. I know the force that's being applied is 10 newtons, but I don't know this friction force and I don't know this friction force. So if I can find those two things, I can plug those in there, get the acceleration, and from there I can get the tension. All right, so I'm going to go then to box 1 being my system here. So if box 1 is my system, that means just this is my system, then that means I'm going to have the normal force from the ground pointing up on box 1, m1g from the earth, that's the weight, the tension force pointing to the right, which is really what I'm looking for, and then the force of friction from the floor acting to the left on that box. So again, I'm going to apply the second law. F net equals ma. Let's see, let's do the vertical direction first. That's going to be, let's see, let's do the vertical direction like this, and the horizontal direction like this. So in the vertical direction, I'm going to get n1 minus m1g, and the acceleration in the vertical direction is going to be 0. So that basically tells me that the normal force is equal to m1g. You know what, we're going to flip these. I'm going to throw this down here, and this is going to go up here. Because I know I'm going to use this again. So in the horizontal direction, then I got the tension force, which is what I'm looking for. This is the big thing I'm looking for right here. Minus the friction force. So that'd be minus FF1 equals the mass 1 times the acceleration. Because this is box 1 is my system here, so I'm going to get M1 as my, my object right there. Okay. And then I can use the fact that the kinetic friction force, that any kinetic friction force is equal to the coefficient of friction multiplied by the normal force. And then I'm going to use this idea that I got the friction force for the first box is going to equal the coefficient of kinetic friction for the first box multiplied by the normal force, which I just found out is m1g. I'm going to take that and save that. All right. Now making, because now I'm going to be able to basically take all this and plug it in there. But before I do that, I'm going to do the same thing here for block 2. So now block 2 is my system. In that case, I'm going to have, that means this is my system here. So if you need to take a look at that, go ahead and freeze this video. Pause this video. But for this system, it's going to be in the vertical direction, going to be in the normal force from the ground on block 2 pointing up, the weight from the earth on block 2 pointing down. There'd be the force F pointing to the right. There'd be a tension force pointing to the left from the rope or the string, and then also a friction force from the ground on block 2 pointing to the left. So again, I'm going to apply the second law, F net equals ma. In this case, I don't think I need the horizontal direction at all, I think. So again, you could do it if you need to do it for any reason whatsoever, but I don't think I'm going to need it. I think all I'm going to need is what's in the y direction. If not, I can always go back to it. So in the vertical direction, I'm going to get Fn2 minus m2g equals 0. There's no acceleration in the vertical direction here. So that means I'm going to get Fn2 equals m2g. And then lastly, I can use that relationship again. Any friction force is equal to the coefficient of friction multiplied by the normal force. And then I'll get that the friction force for block 2 is going to equal the coefficient of friction for block 2 multiplied by m2g. I got that relationship from here, and I'm plugging that in there. So got that. All right. Now I'm basically going to take these, plug that in there. I'm going to plug that in there. And that's going to lead me to, let's see, that's going to be the force minus mu K1 M1G minus over here, which is mu K2 M2G equals the total mass times the acceleration. And now I got everything. Now I got everything, and I'm going to be able to solve for the acceleration. All I need to do is divide everything by the total mass. So that's going to be, let's see, F minus mu K1 M1G minus mu K2 M2G over the total mass equals the acceleration. Plugging everything in. That's going to be, let's see, F is 10, I believe, minus mu K1 is 0.2. M1 is 2. And then G is 10 minus mu K2 is 0.3, I believe. M2 is 1 kilogram. And then G is 10 divided by the total mass, which is going to be 3 kilograms. And there we go. So what's my acceleration going to be? Well, let's see. That's going to be 0.2 multiplied by 10, which is about 2, multiplied by 2 here. So that's going to be 4. And then here is basically 10 times 0.3, which is 3. So it's going to be 10 minus 4 minus 3, which is 3, divided by 3. So I should get an acceleration of 1 meter per second squared. All right. So now that I got my acceleration, I know that this whole system is all going to be accelerating the same. So this block and this block has the same exact acceleration. So I'm going to go back to box 1 being my system. And if box 1 is my system, I can find the tension force using this equation right here. So that's what I'm going to do. I got the tension force minus the friction force on box 1 is going to equal the mass of box 1 times its acceleration, which I know is all this. I'm also going to use this coefficient of friction, M1G, equation relationship into there to solve for this. Sure, I'll plug it in right now. So it's going to be the tension force minus the coefficient of friction for block 1 multiplied by M1 times G equals M1 times A. Now I'm going to add this term to both sides. That's going to give me the tension force equals M1 times A plus mu K1 M1 times G. I can factor out an M1 to make my calculation a little bit easier. So it's going to be M1 A plus mu K1 times G. And now I can plug in everything. Tension force equals M1, I believe, is 2 kilograms multiplied by A, which I just found out was 1 meter per second squared, plus mu K1, which is 0.2, and then G, which is about 10. So that should give me 2 plus 1, all this multiplied by 2. So 2 plus 1 is 3, multiplied by 2 is 6. That should give me a tension force equal to 6 newtons. All right. So hopefully that helped, seeing kind of the details of how I decided to solve it through my solution method. Hopefully that helped, and I'll see you guys on Monday. All right, bye.